Hi everyone. Today we'll be working on solving multi-step equations with variables on both sides. All right, so first I just want to kind of remind you about what we talked in class about today. Today we talked about kind of breaking down the idea of solving an equation into two parts. The first part is simplifying. The second part is then solving. So the first two steps we're going to follow are really just simplifying. We're going to simplify each side first separately, and then we'll go into solve mode. So the first step is to distribute to get rid of parentheses. Second step is combine like terms. So if you remember back to last unit, when we had to simplify expressions, those were our two steps. Once we get through those two steps with both sides of the equation, then we can come down and get into our solve mode. So when we're solving, the first thing we want to do is get our variable terms together on one side by moving or adding or subtracting one of the variable terms to the other side. So we want to try and get all of our variable terms onto one side of the equation. Next, we want to isolate the variable term by adding or subtracting the constant term to the other side. So we want variables on one side, constant terms on the other side of the equal sign. And then our last step is to isolate the variable by dividing both sides by the coefficient. All right, so let's take a look at what this looks like when we are actually solving. So if we think about breaking it down into two parts, first part is simplify. So I'm going to start just by drawing my line, and I'm going to look at my left side. Can I simplify this down any? I don't have any parentheses, so there's no distributing, and I don't have any like terms, so there's nothing to simplify on that side. I'm going to check on this side. I only have one term, so again, I can't simplify. So now we're going to jump straight to solve mode. So remember, we want variables on one side and constants on the other. Right now, I only have one term that's a constant, and he's on the left side. So since my constants are already all on the left side, that means I want to get my variables over to the right side. So I'm going to move this 5a. Now be careful, because remember the subtraction sign really means we're adding a -8. So that minus sign actually goes with the 8. So in order to move this 5a, he's positive. So to move him, I need to subtract 5a from both sides. And when I do that, that will cancel that term out, because they are additive inverses. So now we come down here, right, and we are left with -8 equals -4a. All right. Well, now that my constants and variables are split, now we can work on just isolating the variable. So I'm going to divide both sides by -4. All right, so now once we've done that, remember, our multiplicative inverse says that these two are going to cancel out. All right, so once we do that division, we are now left with 2 equals a. So our a has a value of 2. All right, well, let's just practice putting that into set builder notation. So remember, set builder notation will look like this. Our curly brackets, here's our actual solution, a equals 2. We use that symmetric property to take this and flip it around. And then we just add that line in the other a. And then we circle our answer. Now remember, it's important that we always check our answer. So we're going to come over here, and you're going to write down that equation. And now we're going to use our substitution property, and we're going to substitute the 2 in for a. Right? And now I'm just going to check to make sure. I'm going to do the math for this side to see if it really does equal 2. So 5 times 2 is 10, minus 8 gives me 2. Right? So the reflexive property is showing me that that's true. And that means that that checks. Since these are the same, it means that my answer of 2 is the correct solution. All right, let's go to the next page. All right, let's just do another one. This time, we've got variables on both sides and constants on both sides. So I'm going to draw my line, and I'm going to, again, think about how we're going to split the idea of solving a multi-step equation, and we're going to look at simplifying first. So I look to see, can I simplify this side by distributing or combining like terms? And I can't. I've got a constant term, and I have a variable term. Cannot combine them. And there's no parentheses. And then same thing over here. I've got a variable term and a constant term. All right, so now we want to work on getting our variables together. since I have constants on both sides and variables on both sides, now I have to make a decision. I want to start with my variables, and you decide which one do I want to move. Now, some people just always like moving their variables to the left side. I personally like ensuring that my variables will stay positive, so I look for my smallest variable term. So I've got a 7w and a w. W is my smallest one, so that's the one I'm going to move. Since he's positive, I'm going to subtract 1w from each side. And I like to just throw in that 1 in front of it just to help me remember that there is a 1 there. All right, so then remembering that those are additive inverses, they cancel out. We come down here and we now have 6w plus 2 equals 8. All right, now that I have my variable terms on this side, I now can get my constant terms over to this side. So to do that, I need to subtract that 2 from both sides. Additive inverses once again, those will cancel out, and we are now left with 6w equals 6. So our last step is to isolate that w, so we are going to divide both sides by 6, and now we're left with w equals 1. And once again, we're going to go ahead and put that into set builder notation, just for practice. And then circle our answer. All right, now let's just practice that check. All right, so we want to check to see, is this really a solution? So we're going to write down the original problem, and now we're going to use our substitution property, and we're going to substitute 1 in for every spot that we have the w. So I'm going to substitute in here and here. Now we're going to do the math on both sides in this case because we have a math problem on both sides to do. So you can put the whole thing in your calculator and then put this whole thing in your calculator, and we're going to see that we get 9 for both sides. Reflexive property tells me we're good to go. Put a check mark. All right. Now I want you to come down here and I want you to try these two problems on your own. Go ahead and pause the video now. Okay, let's go to the next page. All right, now we're getting a little more involved with our equations. So this time we have parentheses. That's the first thing I notice. So now I really can break this down into those two parts, simplify, then solve. So I'm going to focus on this side first, and I'm going to simplify this side down as far as I can. Then I'll come over and I'll look at this side. All right, so to simplify, remember when we're simplifying, the first thing we do is to distribute. So I'm going to distribute my 3 to the 2x and the negative 1. And when I do that, I end up with 7 plus 6x minus 3. Now, the second part of simplifying is to combine my like terms. So remember, this is where I like using that strategy of grouping them. I don't change any signs. I'm not using any additive inverses here. Those are all on the same side. We're kind of just ignoring that this part's over here. So I have my 6x, I've got my 7, and I've got my negative 3. Now I can combine them all together, and we end up with that 6x plus 4. And then I'm going to just bring this 9x minus 8 down. All right, so now we can go into our solve mode because I have nothing more to simplify. So I want to get my two variables together. Again, since I have constants on both sides, I get to make the choice. Do we want to move the 6x or the 9x? So once again, I prefer having my variables stay positive, so I'm going to move the smaller one. So this time I'm going to move my 6x over with the 9. I'm going to do that by subtracting. So again, I have additive inverses here. They cancel out. And I'm left with 4 equals 3x minus 8. All right, I'm running out of room, so I'm going to come and bring that problem over to here. I'm just taking that, recopying it. All right, and finishing with my line. So now that I got my variables on the right, I want to now get my constants over to the left. So I'm going to add 8 to both sides. There's my additive inverse. We'll cancel those out. And we end up with 12 equals 3x. Our last step Now we can divide both sides by 3, and we get the solution of 4 equals x. I'm then going to write that into set builder notation. And then, of course, we always want to circle our answer. All right, now let's go ahead and check our answer. So we're going to take the original equation and we're going to write that out. And then every place we see an x, we're going to substitute in 4. So it'll look like this. Now I can use my calculator. I can put this whole problem straight into my calculator to figure out what this side equals. And then I could do the same thing with this side. Put the whole side into my calculator. Remember, I'm no longer testing that you know the order of operations. So now everything can just go straight to your calculator. We find out that 28 for this side is equal to 28 for this side. So we are good. All right, let's do one more together. This time we have parentheses on both sides of the equal sign. All right, so draw my line. I'm going to first work on just simplifying this side. Then I'll come over and I'll simplify this side. All right, so since I have parentheses, again, I have to distribute first. So what's the number? I'm not going to distribute the 5 because there's a subtraction sign. So what am I distributing? Well, let's not forget there's actually a hidden 1 sitting there. So I'm going to distribute that negative 1 to the 2x and to the positive 1. All right, so when we multiply that, remember when we multiply by a negative, it's going to change all of our signs inside. So by distributing that, I end up with 5 minus 2x minus 1. All right, to finish simplifying this side, I need to combine my like terms. So I'm going to just regroup. Remember, the signs follow the terms. The sign follows the terms. All right, now when I combine those like terms, I end up with negative 2x plus 4 on that side. Now I'm going to come over here and I'm going to simplify this side. So I'm going to distribute my 2 to the 4x and then to the 3. When I do that, I end up with 8x minus 6. So there's nothing more I can do here. I have no like terms, so now I can just bring him down. Now I'm in solve mode. Let's get our two variables together. This term's negative, this term's positive. Remember, I like to get I like to keep my variables positive. So in order to do that, I'm going to move the smaller one. No matter what, negatives are always smaller than positives. So I'm going to take my negative 2x and move them over here by adding 2x to both sides. Additive inverse means I can cancel that out. And now we're left with 4 equals 10x minus 6. Now I need to get this negative 6 over with the 4. So I'm going to do that by adding 6 to both sides. Additive inverse tells me those can cancel out. And now we are left with 10 equals 10x. Ran out of room again, so I'm going to bring that back up here. I'm going to draw on my red line and complete our last step. So to isolate the x, we're just going to divide by 10 on both sides. And we are left with 1 equals x. And one last time, we're going to practice putting that into set builder notation. So it should look like this. All right, now let's go ahead and put that into our check. So we're going to put this whole thing in, or rewrite it. Notice I didn't put the 1 here. We don't need to. And now we're going to write it by substituting in the 1 in for both the x's. I can put this whole side into my calculator, and then I can put this whole side into my calculator to make sure that they are equal. And it turns out both sides equal 2. So since they're the same, we know we have the right answer. We're done. All right. Here are 2 more for you to try on your own. Once you finish these, you are done with your notes. So please make sure you complete these before next class. And then when you come in, we'll do some more practice. You can stop the video now.